3, 2, 1.
MDS to,
We have ignition. We have a liftoff.
Right now, a machine built by human hands in 1977 is falling through the dark beyond Neptune. Voyager 1, the farthest object we have ever made, almost 50 years gone, and it has not even reached the edge of our own solar system. Not the real edge. Wrapped far beyond it is a shell of frozen worlds so wide that Voyager, at 38,000 miles an hour, would need 300 more years just to touch its inner wall. No one has ever seen this shell. We know it only from comets falling out of the dark. We call it the Oort Cloud. The Earth sits 1 unit from the Sun, 1 astronomical unit, about 150 million kilometers, the distance light crosses in 8 minutes. The Oort Cloud does not even begin until you are roughly 2,000 of those units out, and its far edge may lie 50,000, even 100,000 units away, close to 1.5 light years. More than a third of the way to Proxima Centauri, the nearest other star. Let that settle. The shell around our sun reaches more than a third of the way to another sun. Sunlight touches your face 8 minutes after it leaves the sun. To reach the inner wall of the Oort Cloud, that same light needs about a week and a half. To reach the outer edge, it travels for 10 months, in some estimates well over a year. Light. The fastest thing there is, taking the better part of a year just to cross one neighborhood of our own solar system. And we have a real machine out there to measure against. Voyager 1, launched in 1977, is the most distant object human hands have ever built. As of 2026, it is about 170 astronomical units from the Sun, still moving at roughly 17 kilometers a second, around 38,000 miles an hour. Its twin, Voyager 2, trails at about 143 units. They are the fastest things we have ever thrown into the dark. And this November Voyager 1 will cross a strange little milestone, 1 light day from Earth. Far enough that a radio whisper takes a full 24 hours to reach it. 1 light day. And the Oort Cloud is nearly 2 light years deep. At its current speed, Voyager 1 would need something like 300 years just to reach the inner wall, and tens of thousands of years to pass all the way through. It will not make it whole. Both Voyagers are dying slowly now, their nuclear power fading by about 4 watts a year, instruments switched off one at a time to keep a heartbeat going a little longer. Long before either touches the Oort Cloud, it will fall silent and keep drifting, blind. The Kuiper Belt, that famous ring past Neptune where Pluto lives, sits a mere 30 to 50 units out. We like to call it the edge. It is barely the front porch. The deeper out you go, the less the sun can hold on to anything at all. Where are you watching from tonight? Same sky, same wall of darkness around all of us. Tell me where you are. Gravity is the leash the sun keeps on everything it owns. Out at the Oort Cloud, that leash goes slack almost to nothing. At the outer edge, the sun's pull is something like 2.5 billion times weaker than the gentle weight holding you in your chair right now. 2.5 billion. Out there, almost anything, a star passing in the night, the slow tide of the galaxy itself, is enough to tip a frozen world clean off its path. Picture standing on one of those icy bodies. You turn and look back toward home, and the sun is gone. Not gone entirely. It is there, but it is only a star now. One cold point of light lost among thousands of others, no brighter than the rest. The furnace that warms every living cell on Earth, the engine of all of it, would not even catch your eye. You could not pick it out of the crowd. These objects circle that faint pinprick, the way insects drift around a single far-off porch light. Barely held, barely lit, suspended in a galactic no-man's land. And they are alone in a way nothing on Earth has ever been alone. Call it a cloud, and you picture something dense, like fog. It is the opposite. The Oort Cloud may hold trillions of objects, and still any two neighbors out there are typically separated by tens of millions of kilometers, farther apart than the Earth is from the sun. Stand on one frozen world, and the nearest other one is more distant than our own star. You would never see it. You could spend a whole human lifetime out there and never learn that another object existed. Here is the part that turns the cold into something closer to dread. The sun's grip is so weak this far out that a single orbit, one slow lap around that distant star, can take millions of years. There are bodies in the outer Oort Cloud that have not finished one trip around the sun since the solar system was born, 4.5 billion years ago. They were flung out there at the beginning, and they are still on their first lap. A whole world, falling around a light it can barely feel, on a journey older than every living thing that has ever existed on Earth. And yet, every so often, something out of that frozen dark comes loose and begins to fall back toward us. For all it's cold, the Oort Cloud sends us letters. We just had to learn how to read them. Every so often, a long-period comet swings into the inner solar system, grows a glowing tail, and hangs in our sky for a few weeks before vanishing again for thousands of years. Hale-Bopp, bright enough to stop people in the street in 1997. Hyakutake the year before. Comet Siding Spring, which slipped past Mars. Each one is a traveler from somewhere very far away. And in the 1930s, 40s, and 50s, astronomers noticed something strange about where these travelers come from. They come from everywhere. Short-period comets, like Halley, ride more or less along the flat plane of the planets, but the long-period ones arrive from every direction at once. Steep angles, shallow angles, straight down from above the sun, straight up from below. There is only one shape that can throw objects at us evenly from all directions. Not a ring, not a disk, a sphere, a shell wrapped fully around the sun. Jan Oort laid out the argument in 1950, building on an idea Ernst Öpik had floated back in 1932. No one had seen the shell. They reasoned it into being from the geometry of falling ice. There was a second clue, and it is the backbone of this whole story. A comet does not last forever. Every time it passes the sun, it boils a little of itself away into that glowing tail. After 4.5 billion years, every comet we see should have crumbled to nothing long ago. And yet, here they are, still arriving, fresh ones every year. The only way that works is if there is an enormous hidden reservoir, far enough out to stay frozen and untouched for the entire age of the solar system, quietly resupplying our sky. We see the comets. We had to invent the cloud to explain them. So each comet is a kind of messenger, a fragment of the original frozen cloud that the planets were built from. It carries the memory of the sun's birth locked in its ice, falling back to the warmth for one brief pass before it returns to the dark. But there is an uneasy question buried inside that gift. What knocks them loose in the first place? Out there, the sun barely holds them, so something else must give the push. And sometimes, that something is not the sun at all. What reaches into the Oort cloud and stirs it is not always our own sun. Sometimes it is a stranger. Because the objects out there are held so loosely, they are exquisitely sensitive. The faintest disturbance can lift one off its ancient path and start it on a long fall inward, toward the planets, toward us. Three things mostly do the disturbing. The slow gravitational tide of the entire Milky Way, pulling on the shell as the sun drifts through the galaxy, drifting clouds of cold gas, and other stars, passing close enough every so often to reach into our outer shell and stir it like a hand through dark water. Around 70,000 years ago, while our ancestors were already walking the Earth, a small red dwarf and its dim companion drifted through the outer edge of the Oort cloud. We call it Schultz's star. The astronomer Erich Mamayev and his colleagues traced its path in 2015. Follow-up work in 2018 found it had likely jostled a handful of distant objects on its way past, coming within about 0.8 of a light-year of the sun. Closer than any other known star has come. For a few thousand years there were two suns loosely tugging at our frozen shell. Then the stranger moved on into the dark, leaving the faintest wake behind it. And the strangers are not finished. There is another one coming. A star called Gliese 710 is drifting almost straight toward us right now, and in about 1.3 million years, it will cut deep into the Oort cloud, passing within roughly 16,000 astronomical units, well inside the outer shell. It moves unusually slowly, which means it will linger, stirring the cloud for longer than a faster star would, and it may send a long, slow rain of comets falling sunward in its wake. We know it is coming because the European Space Agency's Gaia telescope has been quietly mapping the motion of more than 1 billion stars, tracing their paths millions of years into the future. The night sky is not fixed. It is a slow current, and now and then something drifts close enough to touch us. A single nudge out there in the silent dark, and 10,000 years later, a comet burns over your city. The Oort cloud holds the stones, balanced and waiting. A passing star decides when one of them finally falls. If this shell truly wraps around all of us, why have we never once seen it? If you've watched this far, it means you truly care. Don't stop at just hitting like, tap hype too. It only takes a few seconds, but it helps this video reach many more people. We can photograph galaxies 46 billion light-years away. We have mapped the faint glow of the universe as it looked a few 100,000 years after it began. And yet, we cannot see an object sitting less than a single light-year from home. How? The answer is light, and how little of it the Oort cloud gives back. A distant galaxy is made of hundreds of billions of stars, each one pouring out its own light. An Oort cloud object makes no light at all. It can only reflect a thread of sunlight. And out there, sunlight is almost nothing, dimming with the square of the distance on the way out, and again on the way back. Work the numbers, and a body a kilometer across, sitting 2,000 units away, would shine at about magnitude 49. That is roughly 250 million times fainter than the faintest thing our best ground telescopes can detect. It is not that we have not looked hard enough. It is that the light is simply not there to catch. And the sparseness that makes the shell so lonely also makes it invisible in a second way. Because the objects are scattered tens of millions of kilometers apart, the cloud as a whole is almost perfectly transparent. That is why, sitting inside it, we can still see straight out to the rest of the galaxy. Starlight passes through a shell so thin, it may as well be empty. The name fools us. It is less a cloud than the faintest scattering of dust across an ocean of dark. So how do you find something you cannot see? You wait for it to pass in front of something brighter. The most promising method is to watch a distant star and catch the instant an unseen Oort object drifts across it, dimming it for less than a second, a single blink. To catch even one of those blinks, you have to watch thousands of stars at once, very fast, for a very long time. That is part of what a new eye is built for. The Vera C. Rubin Observatory in Chile began its great survey in 2025 and sent out its first science alerts in February of 2026, hundreds of thousands of them in a single night, sweeping the southern sky over and over. For the first time, we may be able to take a real census of the dark edge of our own home. We have not seen the Oort Cloud yet, but for the first time, we have built something that might. And the strangest thought is this: the very thing that makes it invisible, its silence, its emptiness, may also make it a wall. We tend to think of the space between the stars as empty. The Oort Cloud quietly suggests it is not. If our sun wears a shell like this, then so most likely do other stars. And our own shell reaches a long way out, perhaps a third of the way to Proxima Centauri. Follow that thought outward and the gaps begin to close. Our Oort Cloud and the frozen shell of the next star over may very nearly touch at their faint outer edges, trading the occasional drifting world across the dark between them. Which means the void between suns might not be a clean, empty gulf at all. It might be a near continuous haze of cold, almost invisible ice, one star's shell blurring into the next. A frozen no-man's land you would have to cross to ever reach another sun. And in 2025, a supercomputer at NASA found something no one had expected in that dark shell. Running the orbits of countless distant objects forward in time, the simulation showed that the inner Oort Cloud is not a smooth ball at all. The tide of the galaxy has twisted it into a vast spiral. Two faint arms winding around the sun, some 15,000 units across, tilted against the plane of the planets. Our solar system, at its very edge, has quietly grown a shape that mirrors the Milky Way itself. A small galaxy of ice, hidden inside the larger one. We are wrapped not just in darkness, but in a slow spiral we have never seen, turning in the cold. The outer dark is so vast and so dim that it can hide almost anything. including, perhaps, a planet. For years, astronomers have watched a handful of the most distant known worlds, small bodies far past Neptune, and noticed their long looping orbits seem strangely tilted and clustered together, as if something massive were herding them from the shadows. The leading explanation has a name: Planet 9, a world maybe several times the mass of Earth, orbiting so far out and so faintly lit that it has simply never been spotted. It may not exist at all. The clustering could be a trick of where we happen to have pointed our telescopes. But the plain fact underneath stays the same. The space out there is so deep and so dark that you could hide an entire planet in it, and we would not know. We already keep finding smaller surprises. In 2003, we found Sedna, a reddish world on an orbit so enormous it takes around 11,000 years to circle the Sun once, swinging out toward the inner Oort Cloud, though astronomers still argue about exactly where it belongs. Then, in July of 2025, a survey announced only the fourth object of its kind ever found, nicknamed Ammonite, another distant world, this one on a 4,000-year orbit, and a troublesome one. Its path points the wrong way compared to the others, straining the neat story that Planet 9 was meant to tell. And the hunt is about to change. That same observatory, now sweeping the southern sky, is expected to find something like 37,000 new objects beyond Neptune, 10 times everything we have cataloged in all of history. And if Planet 9 is really out there, the summer of 2026 may be when we finally corner it, or finally show it was never there. Either way, the dark is about to get a little less dark. There is one more kind of visitor, and it is the strangest of all. 3 times now, we have caught an object falling through our solar system that did not come from the Oort Cloud, or from anywhere around our sun. It came from another star entirely. First, in 2017, a small dark sliver we named Oumuamua, the first interstellar object ever seen. Then a comet, Borisov, in 2019. And in July of 2025, a third, moving so fast on such an open path that it could only have fallen in from outside, from the dark between the stars. Early study suggests it may be the oldest comet we have ever seen, perhaps 3 billion years older than the Sun itself. A piece of some other star's frozen shell, wandering alone for longer than the Earth has existed, passing through our home just once and never returning. Out beyond our own dark shell are countless other shells around countless other suns. And now and then, the void mails us a fragment of one. And yet, we have barely dipped our toes into that cold and frigid dark. So much of it is still out there, waiting. And the next time a comet hangs in your sky, soft and slow and impossibly far from where it began, you will know what it really is. A letter from the edge. A messenger from the dark shell that has been wrapped around us this whole time. The one we are only now, at last, beginning to see.